This is a little video about beginnings of acid-base chemistry and equations. So the question number one is write an equation for the ionization of nitric acid. So you would have nitric acid, of course. That'd be nitric acid. And then you add it to water. So write these as Arrhenius acid bases, excuse me, as Bronsted-Lowry acid bases. So the H moves from here over to there. I'll let you finish the equation. So what are the two products going to be? Down here we've got nitrous acid, HNO2, and it reacts with water. I'll let you finish the equation, but I'll remind you that this is a strong acid and this is a weak acid. So if it's a weak acid, what will we need to do with these arrows? Will they be a single arrow or a double arrow? And if the answer to that question is it's going to be a double arrow, you're still going to get products that look like these products, but you'll have equilibrium, so you have to put a double arrow in. Okay, this one I'll do completely for you. This is ammonia. Now some of you are going to get confused with ammonia and ammonium. Ammonium is NH4, and I'll show you that in a second. So we're going to react that with water. Now it says the base is a proton acceptor. Ammonia is a base. So if it's a proton acceptor, then you're going to get, instead of NH3, you're going to have NH4 formed. And then the water, of course, lost the proton, so it became a base. Okay, notice that this is a weak base because it's not a group 1 or a group 2 base. So you're going to have a double arrow for equilibrium. All weak things hit equilibrium. All right, and then again, this is called ammonium over here on this side. This is ammonia. All right, number 4, an equation for the dissociation of potassium hydroxide. To dissociate means to come apart. So for strong bases, we don't think about them interacting with water. We think about them as a solid becoming ions. Would there be a double arrow or a single arrow here? So that'd be single because that's a strong base, and strong bases don't hit equilibrium. All right. Number 5, you've got a 0.2 molar solution of a weak acid that's 3% ionized. So you got HA. I'm going to use A as an anion, just any anion, because it doesn't tell us what the acid is. We're going to react it with water. When we do, we develop this ion here. It's called the hydronium ion. And, of course, you're going to have A minus left behind with a negative charge. Since it's weak, what do we know about these arrows? These would be double arrows. All right, now we know that initially, this is an ice problem, you might recognize it. Initially, you know this is 0.2. But 3% of the 0.2 ionizes. So what you need to do is find out what 3% of 0.2 is, and that will be x. So it's going to be minus x, but we know what x is. X equals 3% of 0.2. All right, so once you know what x is, you can find the concentration of this and this and this. So you guys solve for the Ka. All right, we're going to find the pH and the pOH of 0.5 molar acetic acid. So acetic acid is this. You're going to react with water. Weak acid, so you have double arrows. Okay, we need to find the percent ionization. You know the original concentration is 0.5. Now again, you're going to finish this equation. I'm not doing that for you. So this is an ice problem, ICE. So it's 0.5. You're going to take away X amount. And at equilibrium, you have 0.5 minus X. For the things that are over here, you'll have X and X. You know the ionization constant. And this is a mistake right here. This should say Ka. Ka. So fix that mistake. So Ka is that. So 1.8 times 10 to the negative fifth is equal to products divided by reactants. Remember that? Okay. So after you know what X is, you're going to use it for all the rest of the question. So once you know what X is, X divided by 0.5 will give you the percent ionization. And then X is also will be the hydronium ion, so you can find the pH by taking the negative log, then subtract from 14, you get the pOH. All right, this one, you got ammonia. Do you remember the equation for ammonia? I think we did it earlier. You finish it. Okay, we know this was 0.2. X amount reacts, so at equilibrium it would be 0.2 minus X. We know the ionization constant. You know this is going to be X and X. So once you know what X is, that will be the hydroxide ion. So X equals the OH minus concentration. If you take the negative logarithm of that, what do you have? pH or pOH? pOH. So to find pH, which is what the question asks, you're going to need to subtract that from 14. All right, and down here, you have lithium hydroxide. Would that be strong or weak? I'm hoping you're thinking strong. So single arrow. So if this is 0.2, then these will both be 0.2 as well, because there is no equilibrium. So the 0.2 over here is going to go completely away. That's 0.2, and that's 0.2. So if I take the negative logarithm of 0.2, what would I have? You take it from there. And that's the end of that little session. So I'll get these answers worked out properly, prepared to turn them in on Tuesday. All right, bye. Have a good weekend.